Okay, I'm going to look at an example of generating a model transformation from an example model, known as model transformation by example. And the case is the classic UML to relational database case, where the source language, the source meta model, is a simplified UML class diagram notation, and the target is a simplified RDBMS. This is the example that's in the QBTR standard, and it's a classic example of a model transformation. It's of moderate size. There are 8 source classes and 6 target classes, but there's quite a big change in the structure from the source to the target. The source has, for example, inheritance, and so UML classes have a number of generalizations, they have a number of specializations. This relationship is entirely missing in the RDBMS model. Tables are isolated, they don't have relationships with each other, and what this means is that the attributes of a class, so the attributes that are owned by a class and attributes of ancestor classes, have to be copied to all tables that represent a class and its descendants. In other words, each attribute here is going to be represented by multiple columns, one for each class, in which one for each table corresponding to a specialization of the original owner of the attribute. There are also other changes. For example, here we have UML type. This is an optional attribute here, but in the RDBMS this is mandatory. Likewise, the owner of an attribute is optional here, but here the owner of a column is mandatory. So there are many changes between these two languages, and therefore it's quite a difficult problem to write a transformation. It's a challenging problem, but by using a relatively small model we can induce an accurate and efficient transformation. So all of the steps that you need are on this menu to do the model transformation by example. We just loaded the transformation here from mm.txt, loaded the meta models from mm.txt. Load the transformation. If you already had some initial transformation, you can load that in notation TL, but there isn't one in this case. And the main step is to check with respect to a model. Now the model is a example where we have source elements, in this case 2 packages, 4 classes, and we have the classes arranged in an inheritance hierarchy so that class C1 has 2 subclasses, C2 and C3, and C4 is isolated. We have 2 primitive data types, integer and string, and we have 3 attributes. The attribute A1, because it's declared in C1, its owner is C1, it will actually have copies effectively in C2 and C3. There's 2 associations. In the RDBMS model that corresponds to this, we have 2 schemas corresponding to the packages. The correspondence is notated by this little arrow notation. And we have 4 tables corresponding to the 4 classes. We have 5 columns corresponding to the 3 attributes because of the fact that we have copies of the first attribute in the tables for class 2 and class 3. So what we have here is called instance replication. The A1 is replicated to table attribute 1, table attribute 1 copy, and table attribute copy. So we've got 3 versions of the first attribute. We also have keys for the table. Each table has a key, and the associations are mapped to foreign keys. So this sets up what is the essential idea of that transformation as a simple model with 12, I think, elements, not very many elements anyway. As you can see there, it's quite a small example. Okay, to use that, we take this option and we can see what's going on by looking at the file here. For example, we check, the system checks if the name of a class corresponds to the name of a table, and it does, and so we get a copy feature mapping, but there's many other kinds of matching which are checked as well. And here we're checking if there's a specific function on particular things from UML name to id, and there isn't. So in these cases we're going to just answer no for specialized functions. Okay, so what we get out is a transformation in this TL notation, which is a very concise notation for saying what the mapping is. So package is mapped to a schema. The package, string package, is always going to be the kind of the schema. The name is an attribute to the name and the ID to the ID. The UML owned element of a package becomes the RDBS table of a schema. It's fairly straightforward. Correspondence. The interesting thing here is the instance replication, in that for each class which is either the owner or the specializations of the owner, we get a copy of an attribute as a column where the name is the same and the ID is the name. The type is the sum of the names of the types in the source. In other words, we're concatenating the names. We get the empty name if there was no type. And the owner of that column is the parameter here. So for every class in this range, we get a table here mapped to the owner. Okay, so that's the abstract specification, and it is complete. In fact, it's over complete because we've got mappings to the inverse of an association as well as to the forward direction of an association, and probably we'd want to remove those redundancies, but I decided to include them all so that you can see the whole transformation, but in practice it's only necessary to map to one direction of an association, not to both ends, both directions. Okay, so there's our abstract specification. We can convert that to practical transformation languages by this option, maptl to bx, and we get QBTR versions and we get UML RSDS versions, whereby they're put into these files. Put into the files UML RSDS code for the UML RSDS. So we get a UML RSDS transformation which consists of a number of constraints. Here, for example, we copy a package to a schema. For each package there exists a schema with the same ID, and so on and so on. And the copying of objects, of attributes to multiple columns comes here. And this is a fairly short specification. The interesting thing with this, though, is that we can type check it. It becomes part of the UML model here. We get the actual phases, first phase copying, second phase linking, and we can type check it, generate design from it, get some warning messages, but none of those are serious, and we can generate Java 4. That Java 4 is compilable and runnable. Let's see what it does. Run it, Java GUI, load a model, we get the different phases. I've put in here some timing information, but you wouldn't normally get that. And going to this example, if we feed in the input side of that, in other words, the UML side of that, as the input model to this code. So we have this input side, but without the RDBMS part. And we've run it, and we've saved the model. The model comes out in the file out. We should get more or less the original model that we had in the RDBMS version. So we have a column here, and we have a column A1 for the class 1, A1 for the class 2, A1 for the class 3, and so on. So we get these 5 separate attributes, 3 of which are copies of the A1. 5 separate columns representing the original attributes. Notice these all have the name A1, but they're sitting in different tables. Their owners, we get a table for each class. Their owners are, as you can see, different tables. We also get foreign key for the association, and it links the classes. And then you can ask, well, is this efficient? And the answer is yes, because not only can I run this with a small model like that, but I can run it with a large model of essentially 100,000 copies of that, which comes to about 95 megabytes, as you can see. And running that is also quite reasonable in its execution time. So I can load that one. The loading takes a little bit of time with 95 megabytes, but the actual execution of the transformation is quite brief. So it loads the model. The first phase, the copying, is less than a second. The second phase, the linking, is also, so in total, less than a second to handle a model of size 95 megabytes. Okay, so in the next video we'll talk about other approaches to transformation synthesis.